All right, hello, can y'all hear me? Team Green, wave at me if you can hear me. All right, very cool. Hey, I'm glad you guys are here, public sector. This is very cool. My name is Eric Johnson. Let's see if my deck is up there. We'll hit there. 12 factor, there I am. That's me. So, I'm not pretty, but that's all right. My wife says I don't have to be pretty, I don't have to be right, I just have to be funny. So it works out for us. So I'm glad you're here. And a little bit about me, just so you know who I am. I am the Serverless Developer Advocate. I'm a Senior Developer Advocate for AWS, talking about Serverless. My Twitter handle is EDJGeek. I encourage you to follow it. I talk about Serverless a lot. I also talk about my kids and family and weird things a lot, so you know, good with the bad. I am senior developer, talked about that. I'm a big nerd on serverless tooling, automation, those kind of things. I just realized there's a screen in front of me and not just behind me, so that's gonna be really helpful. I am a dad of 5, okay? Yes, that's not a typo. I am a dad of 5. I'm a husband of 1. And I am a musician, but a lot of people say drummers aren't musicians, so I'm a drummer. So, okay, we got some excitement out there. We got some drummers. So, a couple of things. I have a couple of rules when I'm talking, okay? And I know you're looking at me going, who are you to make rules? Well, I'm the guy up front with the mic that talks to green, right? So the first rule is this, and really they're more guidelines. They're gonna help you out, but it will be handy. The first rule is this. This is any number I want it to be, okay? I'm not kidding you, because I will say things like there's 7 of us, there's 9 of us, and someone in the back always be like, that's a 1. I know math, that's a 1, okay? These are quotes, not apostrophes. I know that, okay? And these are thumbs. I'm not just pointing at myself. My college ID was this. And everybody's like, why is he pointing at himself? So, I do like to have some fun. I will tell one-finger jokes. It might make you uncomfortable, and if that does, you're gonna be uncomfortable, because I'm gonna do it. So, but we are going to have some fun. Public sector, this is very cool. I'll tell you, last year I went to the public sector party at reInvent, and there's a lot of people that think they know how to throw a party, but public sector knows how to throw a party, okay? Let me tell you why. You guys had a donut wall. Okay, now if you haven't figured it out, I was born to eat donuts, okay? Or make them, you know, so I was very happy. All right, so let's jump in here. I could tell jokes all day, but you probably want to hear a little bit about serverless. So why are we here today? Okay, so we're going to be talking about what does serverless mean today, or what does 12-factor serverless applications mean, okay? So we're going to jump in here. 12-factor model and serverless applications. So what is 12-factor? Has anybody ever heard of 12-factor? Okay, excellent. So let's do this real quick. How many of y'all are using serverless currently? Alrighty, okay, excellent. How many of y'all are looking to get into serverless? How many of y'all are in the wrong group and you're not sure what I'm talking about? Okay, that's what you got. One guy raise his hand. It's over there. So, okay, great. So the 12-factor it was written by, popularized by developers building large-scale applications on platforms such as Heroku. Okay, in recent years, 12-factor guidelines have really become best practices. So what people do is they look at this and go, you know, this is how we should build our app. And the great thing about 12-factor app or 12-factor development model is that it applies. It doesn't matter what language you're using. Doesn't matter, you know, the framework, stuff like that. It's good. It's just good practice. Okay, so we want to talk about how does that apply to, you know, serverless. So there's some key things in 12-factor that we want to point out. Okay. So first of all, when you look at this, and I could read this to you, but the main things I want to call out are the 12-factor app is a methodology for building software as a service app that, number 1, let me try the button again. Number 1, use declarative formats for setup automation, okay? So that means that when you have new users coming in, they should not have to spend 17 days ramping up. Have you ever been that new guy coming in going, okay, here's our application. It's going to take you a year to get it set up on your computer, and then you'll probably get fired, but good luck. So I've been that guy, and that's a panic. That's a stressful day, okay? Second thing, number 2, what number? All right, there's somebody new in the back. It's the 1. Alrighty? Have a clean contract with the underlying operating system. You should not be reliant on the underlying operating system. You should be able to move around. You should be able to take that and move it fairly easily. Okay, number 3, are suitable for deployment on modern cloud platforms. Hello, this is important, right? Okay, so we don't want to have to always be reliant on old technology. We don't want to be able to move forward, okay? Cloud, obviously I'm a proponent of cloud, and that's modern. And we want to be able to do modern application, get the efficiency, the scalability, the cost savings, all those kind of things. There should be minimum divergence between development and production and enable continuous deployment, okay? And we'll talk a little bit more about that, okay? But man, have you ever been that developer when you're working on a project and you get to, you build it and everything works locally, but your production environment looks entirely different? Like, oh yeah, we don't run Windows in production. Okay. Wish I'd have known, because I uppercased everything, right? So that's always been my thing, case sensitivity between, Linux and Windows. So they should match, right? Okay, and finally, can scale up without significant changes in tooling, architecture, or development practices. Okay, and I would add, can scale up without having to call me at 3 in the morning and say, hey, turn on another box, right? Because that's not fun. Okay, let me grab a drink of water here real quick. All right, so let's jump in here and look at understanding serverless. Now, this is a very basic. In this, we're not going to go through the entire definition of serverless and how it works. But I will tell you, it's serverless. There are no computers. There are computers, but you don't have to worry about it. I'm not going to lie. I walked up this morning, and I've never done a presentation. There's no computer here. And I got all excited. I said, our presentation is serverless. This is awesome. So it's not the case. Apparently, it's in the back somewhere. But, so when we talk about serverless, it's really kind of a basic idea, okay? When you think about how it works, or we're going to talk about it in a basic idea, there's some more complexity that we worry about, not you. But the basic idea of running serverless is that you have an event source. That event source could be really a number of anything, okay? It could be a change in data state. It could be a request to an endpoint, change in resource state, file dropped in a bucket. I mean, there's roughly 50 different events that you can use in AWS to trigger your Lambda, okay? So that triggers a function, and you can run, and this is not an exhaustive list. You can do Node, Python, Java, C#. We have a runtime API that allows you to do pretty much anything. We've seen COBOL on there. We've seen Elixir, Rust, R, all kinds of things. So a lot of power here to run the language you want. And the Lambda then does something, okay? So event triggers a Lambda, and the Lambda does something. Okay, very technical right there. Something, okay? And so it could be, scale an image. That's the ever popular hello world of Lambda. We're going to scale an image. It could be recognize an image. It could be translate, something like that. So that's kind of the idea of how a serverless does. Now, some of our most common use cases that we see, not in any particular order, but web or mobile backends, okay? We see file processing, again, drop something in a bucket and we do something to it. We see queue processing. Queue processing means, hey, I'm going to use like an SQS, I'm going to stack it up with stuff that I need to happen, and Lambda will do it in batches for us. We can do Amazon Kinesis, real-time stream processing. You can do some crazy stuff with that. You can attach to Lambda streams, or I'm sorry, attach to Kinesis streams with Lambda, and you can work with that data in real time or near real time, so you can get very hot data. Amazon SNS, notification processing. This is where we broadcast out, and then you have Amazon CloudWatch. I was talking about this with someone earlier. Does anybody run a machine that runs cron jobs? Okay. You're going to hug me later. I'm going to save your company and you $1 billion, okay? Maybe not. Don't quote me on that. Come back to AWS and demand $1 billion. But you can, in Amazon, you can run an event trigger in CloudWatch. You can set a time on it, it's just like cron, okay? You have different options. And then you can trigger a Lambda. And because you have any language of Lambda, you can run Bash scripts, you can run PowerShell scripts, you can do all kinds of things. So rather than paying the money to keep a server up and running to run tasks, why not just pay for the individual invokes, okay? Something to think about. All right, so let's get into the 12-factor and how it applies. So let's explore how the 12 factors apply to service applications. When you look at, here they are. I'm not going to read them all to you because we're going to go through them, but we'll kind of jump in here. So number one, the code base tracked, and code base should be, how's it going? One code base tracked and revision control, many deploys, okay? So you should have, all code should be stored in revision control. This could be something like GitHub, very popular, Bitbucket, code commit, still people, some use SVN, all kinds of things. So, but there's a lot of times we get questions on how do I break an application up? Where do I put things? And is it mono repo, multi repo? This is a big debate. This is almost like tabs and spaces. Okay, mono versus multi repos. A best practice that we look at, and we say if events are shared, so you have a common API gateway. So let's talk about web application. If those events are shared, they create an application. It's one application, right? So we store that in one repository. But if otherwise you break them down, okay? So if I've got multiple API gateways or I'm doing separate things that aren't tied together, I'm going to save them off as separate applications. And I'm going to use different repositories. So this applies to serverless apps in that your code is stored in a repository, just like any other deployment. And I can't imagine, but if there's anybody in here not using a repository, you're grounded, okay? I have to tell you. Because the reason for a repository, number one, rollbacks, right? We want versions, we want to be able to pull it back. Number two, early merging, okay? So when I work with my developers, I tell my developers, look, you need to be committing daily, several, 3, 4, 10, 12 times a day. There's always that one developer that commits every 3 weeks, and he breaks the whole thing. So that guy's grounded too. So I really encourage you, if you're not using a repository, look at a repository. So number two, dependencies, okay? Dependencies should explicitly declare, or be declared and isolated, okay? So what this means is code that needs to be used by multiple functions to be packaged into its own library. Don't repeat yourself, okay? That's the dry method, or dry principle. Okay, don't repeat yourself. If you find yourself writing the same function in every Lambda, don't do that, okay? What you want to be able to do is you want to be able to share that library so that you're not repeating yourself, okay? So really what that comes down to, you can do zip files, you can see the different languages. These are just, again, just some examples. But the best practice that we talk about are Lambda layers. Who's heard of layers? All right, okay. All right, now I could ask that again, and everybody should raise their hand. I'm going to tell you about layers right now. What layers allow you to do is you can create your own library. So there's a couple things you can do with it. I'm a Node guy, okay? I don't apologize for that. I am. So what I learned, I was a front-end guy first. So with Node, I can package. Let's say I use Lodash a lot, which is it's a utility library, and I use the AWS SDK. So I have a layer that I created that all that's installed, okay? And I can version that. So I'm going to push it up to my AWS and I can version it, and I can share that to either other people or publicly. Now, when I create a new project, instead of me rewriting all those functions that I did and bringing in those bringing in those libraries, I just connect to that layer. All right, so let me tell you what happens. When the Lambda is placed, the layer is placed into the execution environment, okay? So when you create or update the Lambda, they go and grab the layer based on your version and they put it in the environment. And then even if that layer is deleted by the producer, it's still in your Lambda, okay? So you look at that and go, well, what about locally? What if I'm developing locally? Well, if you're using Sam local, it also brings down that layer, and it's just as if you were using it just as if the library existed on your machine. So don't repeat yourself, okay? So again, using Lambda layers, kind of what I just explained on how it works. They're immutable. When a version is deleted, it doesn't hurt you or the permissions are done until the next time you try to install it, okay? So there may be a reason why the creator deleted it. So when that version's gone, then you can't, next time you update or create a new one, you'll have to update the version or change that out. All right, so number 3, config, okay? When we talk config, we talk about things like, what is the configuration of our application? What is the, what are the parameters that we need? What are the database passwords? What are the, the API endpoints for some different services that we need? Excuse me. So these configs should be stored in the environment. That's the 12-factor declaration. They're stored in the environment. Don't store them in your app. Okay? 1, it's hard to maintain. 2, there's a chance when you push it to a repository, you push a password there. That's always fun. I always like being that guy. Did you know you push your password to the... Yeah, I know. It was intentional. It was a test. Okay, you passed. You get to keep your job. Go ahead and forget that, and let's roll that back. So, with serverless apps, there's a lot of ways to do this, okay? AWS has a lot of ways to store secrets, okay? There's Lambda environment variables, okay? You can do, these are key value pairs available via standard environment variables. You can push them with your SAM templates or with your CloudFormation templates. This supports KMS encryption, which is your key management service. There's API gateway stages. So this can be done. So if you're using API gateway in front of a Lambda, you can actually have your parameters there. So based on a different stage that you're using, maybe a version 1 or version 2, you can change those and pass it in. And finally, there's the AWS Systems Manager parameter store. And this is probably one of my favorites because the way the System Manager works is a centralized store to manage your configuration data. And it's account specific, okay? Where this gets really helpful is when I set up an environment, let's say I have 20 developers, okay? I'm gonna set up probably 23 accounts, okay? I'm gonna have a developer account for every one of my developers. They don't have to share and parameterize and things like that. And then I'm gonna have an account for let's say alpha, an account for beta, an account for production, okay? However you wanna do that. So, what I'm able to do is I'm able to store account specific, like developer specific stuff is stored in their parameter store. Then the ones needed for alpha are stored in the alpha account, and so on and so forth. See what I'm driving at? So as I move my code through there, as my developers are pushing code into the repository and I'm using a CI/CD, which was talked about in the last session, if I'm using a CI/CD, they're grabbing those new parameters and it's always relevant to the environment. So it's a great way to store these. They can be encrypted. You have a lot of permission control around them using IAM, so great way to do it. Library, you can also grab, so you can grab these from the templates, those can pull them in, but you can also grab parameters right from the code using the SDKs. This is an example of Python. I think, I don't do Python, so that's not true. I can do a little Python. If I'm the last guy in the world, I'd probably still look for someone else, but I can do Python if you need it, so. All right. So let's move on. So the fourth one we're going to talk about is backing services, okay? And when we talk about backing services, we're talking about things like, our database, our queuing system, our, different things like this. So they should be treated as attached resources. They shouldn't be, they love me, they shouldn't be written into the application, okay? All right, so in serverless apps, this is no different, okay? Resources that AWS Lambda functions connect to, such as databases, should have their own endpoints. And that's the way serverless works, is we talk through endpoints most of the time, okay? And so treat those as separate applications and treat them as attached resources. All right, number 5. It was always fun in Marco Polo. Marco. Quick, there it is. I like that. Someone's awake. Okay. All right. So build, release, and run. Strictly separate build and run stages. Build, release, and run stages. Okay. So what this is talking about is if I've got a process, okay, and this is no different in serverless, okay. We use tools like code build and code pipeline to make this happen. But what we're talking about is my build process should create an artifact, okay. My release process should grab that artifact and hand it to my run process, okay? And those should have strict lines between them, okay? I shouldn't be changing code in my release process, okay? Because let's go back to that new guy who comes in. Well, where is this change? Oh, that's in the release process. Well, that makes sense. Not at all. Okay, so you want to break these down on how they're going to work. And so when we do this, and we even, you can even get very granular, and you can also, okay, I have my build process, I have my test process, and those could be, depending on the order, if you're compiling, however you're doing, a lot of different ways of doing that. I have my release, or my release process and my run process. So we use inside of the code build, we have ways to handle this, okay? So this is an example of code build. Anybody using code build right now? All right, okay. I really encourage you to look at code build. Code build's very powerful. And I've always said if you could do it in a terminal, you can do it in code build. Because how it works is, I mean, it's a really simple idea in that it brings up a container and it runs the commands you give it. So if you're running, I mean, as developers, we're, in npm run tests, or whatever language you choose to use. So we can do that in the terminal on code build through the build spec file. So this kind of gives an idea how this works. And you can pass variables in, examples of what you can do. There's different phases. There's an install, a pre-build, a build, and a post-build, and then it generates your artifacts, okay? You can test here if you want, or you can bring up code build again and run tests against the artifacts that were passed from the previous one. It's up to you. But you have a lot of ability to break that down. So when you build an example of when you're working with code build and you build these pipelines, here's an example of a minimal developer's pipeline, okay? So what would happen in this process that we're talking about is you would commit code into your code commits, our example here. It would get triggered and it would test and build the source, okay? So in this, we're kind of combining it all. It then passes it over to the deploy, okay? So we're running CloudFormation. Because we're running serverless here, we're running CloudFormation. And what it's gonna do is it's gonna create a change set, because we always wanna check our work first, right? It's just smart, okay? So we create a change set and say, hey, does this look valid? Yep, that looks valid. And then we do an execute change set, and we make that change. And we can run stubs on this. We can do, and we won't go into this, but you can do with Lambda, you can run pre and post hooks for Lambda. So when you bring up your new code, you can say, hey, use another Lambda to check this Lambda. Is it working? Great, release it. And now that it's released, check it afterwards. Oh, nope, it's not working. All right, roll it back. A lot of power that can be done here, okay? All right, so when you get a little more complicated, this is a production pipeline, right? So this carries it out. So the same thing, again, we commit our code, we do our build, we go to our deploy and testing, which we saw in the earlier one. Then it deploys to staging, okay? Now these are different variables, different environment stuff, because one, we've either done it in parameter store, so we can grab it there, or two, we have stage variables at this particular setup, okay? Same thing, we run the API test, looks no different, except for, do y'all see right at the bottom of this, the second column, it says QA sign off, okay? You could put a manual sign off in a pipeline. Very cool. So what this does, this emails or texts someone and says, hey, this is out there, take a look. They go look at it, so eyes on screen. You always want eyes on screen, right? They go, okay, then they can push that button, or when they do the review, they can click, and it'll actually continue the process. So a lot of power here that you can do. So again, break those processes out. All right, so now we're gonna talk about process, okay? We just talked about process, but this is a little more literal when we talk about application processes, okay? So execute the app as one or more stateless processes. How many of y'all are still working in stateful applications? Okay, good. How many of y'all work with stateless applications? All right, good amount. Good. I encourage you to start looking at that, because that's a lot of times where you lose data is when things crash, things like that happen, and it make them hard to scale out. But the idea here is to do stateless processes, okay? And this is inherent on how Lambda is designed already. So so Lambda should be treated as stateless. There's no place in Lambda to store data, okay? And there's an intent on that. So you don't want to write it, because that Lambda is ephemeral. Okay, it's going to be gone before you know it. So they're treated as stateless. There's no promise of execution, environment, reuse. So what I just said, when a Lambda's warm, there's a good chance it's going to be reused. Okay, but it's not a promise of it. Depends on if it goes away, timing, moved to the machine, different things like that. All right. The data that needs to be kept should be stored off Lambda in stateful services such as DynamoDB, caching. There's different things you can do there. So. That's definitely, again, that's an inherent thing in serverless, so we meet that declaration. Port binding. So, export services via port binding. Have you ever seen this? If you've run like PHP, you might roll it off to like Apache on a different port, different things like that, okay? Well, this doesn't really apply in Lambda because it doesn't, I'll just read this. It doesn't apply the same due to a difference in how Lambda functions are accessed, okay? We're gonna talk about how they're accessed. Basically, instead of a port, Lambda functions are invoked via one or more triggering services, okay? Like we talked about, if I drop something in a bucket, it's gonna get triggered, okay? So we're not really routing ports anymore. It's just kind of one endpoint all the time. So let me show you how that works. So whenever a service calls Lambda, it invokes the Lambda API, okay? So the Lambda API is a synchronous call. Well, it supports sync and async, but it's used by all the other services, okay? So that's how Lambda's talk to. It's an endpoint, okay? So it's not a different port. We don't have to write different ones. We don't have to worry about scaling these up or anything like that. Or you don't have to. We handle that for you. So what that comes out to, when you look at the Lambda execution model, there's several different ways it'll work. All of them use the invoke, okay, like we just looked at. But in the first one, we have a synchronous call, which is like something like an Amazon API gateway. You make a call to Amazon API gateway, it makes a synchronous call or invoke of the Lambda, gets a response to the user, okay? An asynchronous event is something like an SNS or an S3 or SQS or different things like that, where and this is when you're looking at serverless patterns, and this isn't really serverless pattern talk, but when you're talking about that, you really should be looking at how can I stop my user from waiting? How can I say, we want them to be able to move on while I take care of the work? So I'm going to do asynchronous calls. So I'm going to push stuff to an SNS. Okay, SNS will trigger my Lambda, it'll do the work, then we'll get back to the user, okay? So these are very asynchronous type calls. Pull-based is another way it works. Now again, it still uses the API Lambda gateway, but the Lambda service handles this for you. So when I'm using pull-based stuff like DynamoDB, and this would be like the streams coming off of DynamoDB, and Amazon Kinesis, as changes happen, AWS Lambda service pulls the Lambda for you. You can set batches, things like that, and then it does the work. Okay, so again, another pattern is rather than having to write to Dynamo and get the data back, do something else, I can write to Dynamo and then trigger something off the stream on the backside while my customer is able to move on until we get back to them. All right, so again, talking about how processes work, this is how it works in serverless. So next thing we're going to talk about is concurrency. Concurrency is always fun to talk about. How fast, how much can I handle, right? So scale out via the process model. So what the 12 factors is saying is your process, you should be able to add more, right? And build up, okay? So this doesn't apply to Lambda, okay? As Lambda functions will scale automatically based on load. So as you get more traffic, we'll handle more load. We've got the stuff out there to handle these spikes, okay, that are going on. Okay, you can fork threads inside your function execution, but there are practical limits due to memory and CPU network, and we'll talk about that here. So you can tweak your function to deal with functions on the computer power. Okay, so like a Lambda exposes only a memory control. There's two knobs you work, or there's one knob you work with. I'm sorry. Lambda exposes memory control, and that directly affects the amount of CPU you have. More memory, more CPU, okay? Is your code CPU, network, or memory bound? If so, it could be cheaper to use more memory, okay? You're saying, Eric, are you crazy? Because we charge, on how much memory you use. Actually, yes, take a look at this, okay? Now, the first thing I'll point out is I know that color down there where it says red, I realize that's not red, okay? So pretend when I say red, it's blue. I'm not even gonna tell you why, okay? We'll just say, I made a mistake. It was a mistake. Okay? So when you look at, so let's take a look at our example, all right? We have stats for a Lambda function that calculates 1,000 times all prime numbers, okay? Less than or equal to 1 million, okay? 1 million, all right? So at 128 megabyte, it's 11.7 seconds and costs us 0.024, okay? Remember, that's red, and red is bad, okay? Someone in the back, that's not red. It is red, okay? It's any number I say, any color I say, okay? At 256, we get a little better. But look at the 1024, 1.46 seconds, all right? So 1/10 the speed, right? it's much faster. I'm lousy with numbers. I only got to 2 in math. Alrighty, you're like, that's rude. Okay, so 1.4 seconds, much faster, right? But look at the price, 0.02462, and then it's beyond what I would count and care about. All right, so your price is almost exact. You're much faster because you raised your memory. Okay, so understanding your application and how it performs is critical. All righty, and the cool thing about Lambda is you can test it almost free. Because I don't know if you know, but the first 1 million invokes are free, and that's per month, and that's not just for the first year in free tier, that's always, okay? So Lambda is a great way to start up, to prototype, to proof of concept. Just try it. Hey, I wonder if this works. Just try it. Spin it up, okay? All right, so as you can see, we did the math here, minus 10 seconds. All right, disposability. So what this means is maximize robustness with fast startup and graceful shutdown, okay? So when you're scaling and you want to be efficient, your app needs to start fast and it needs to be fast, okay? Right? We spend half our time optimizing our code. How much better can we make this? Now, the interesting thing, shutdown doesn't apply here, okay? Because you're not going to shut your Lambdas down. You're not going to worry about that. However, speed does matter. Okay, so how fast can your Lambda come up? And we look at things like package size, the language used, are you in the VPC or not, and pre-handler code calls, different things like that. So there's different things that affect how you're going to speed this up. So there's a couple of things you can do on Lambda to help you figure it out, okay? One of the things is called X-ray. Anybody use an X-ray? All right, anybody had an X-ray? No, that's personal, don't answer that. All right. So X-ray, what it does is it has a global view across all your services and allows you to find the bottlenecks, okay? It allows you to see, why is this call taking so long? Why is this service taking a while to respond? And so you're able to track that and start working through the code. Okay, start fixing your architecture application. So you get a trace. So when you add this, it's very powerful. You can API gateway inserts a tracing header into HTTP, and so it tracks it there. Lambda instruments, it's already added on Lambda, but you can actually talk to X-ray from within your code. So you can wrap your library and say, anytime you call out, I want you to do a trace on it. So I can say, hey, this call to DynamoDB is horrible. I wonder why. Well, you're scanning a million insert database every time you call it. That's bad, okay? Let's look at doing get item instead of scan, all right? Or having secondary indexes. Whole other session, all right. So this is what, when you look at an X-ray, this is what a trace example looks like, okay? And so what you're able to do is say, okay, what am I seeing? You know, what's going on, you know, in this example, and it kind of breaks it down into the different things. You can see down here under S3, we've got an error or a large latency. So it gives you some idea of how that's going to work. All right. So dev prod parity, this is number 10. So what 12 Factor says is keep development, staging, and production as similar as possible. I said we'd come back to this. Man, that is the biggest pet peeve of mine. Okay, that drives me nuts. Oh yeah, in production we only run 2 mega of RAM. That's problematic. Okay, it should look like at least, I understand that your development and your staging may not be identical, but your staging and production should. A lot of times we say, well, yeah, but we're running the same architecture, we're running the same, you know, processors, we're running the same this or that. But what we don't account for is load on those, things that can affect our app in timeouts, different things like that, okay? So when we're talking environments, we want parity between them, okay? So serverless apps, this can be made incredibly easy with serverless applications by making use of the stage variables we talked about, or parameter store, okay? Using the serverless application model, SAM, okay? And having CI/CD process and tooling that supports multiple environments, okay? So serverless is very easy to do CI/CD on. It's very easy to have matching environments, okay? Let me introduce you to Sam. Anybody met Sam before? All right, that's the most exciting part. I know Sam. Okay, so SAM is the serverless application model, and this is I don't think it's official, but it is official. Our mascot is a squirrel. I feel tough right now, okay? So this is our mascot. So let me tell you about SAM and what it does. Okay, SAM again is the AWS serverless application model, and there's several things that are included with this. The first one to talk about is the CloudFormation templates, okay, the SAM templates, which are CloudFormation templates. Okay, so the cool thing about this is it's a CloudFormation extension optimized for serverless. So when I do like a serverless function, I can build a serverless function in maybe 6 lines, whereas in CloudFormation it's 96 lines. It can be kind of painful sometimes, right? So I'm able to build those very quick. A DynamoDB table, 2 lines. You can do that minimum, right? So it supports anything in CloudFormation. So you could literally say, look, I'm not dealing with serverless, but I like SAM, so I'm going to do that anywhere. Or I have a hybrid, so you can bring those in. It's open specification. You can see the website here. So let's look at what that looks like. So you have a template. This is creating a function. Okay, let me tell you what this means. Okay, so the first thing you have, actually, let me go to the next slide here. It'll point it out for us. So the first thing you have on top is it tells CloudFormation, hey, this is a transform. This isn't standard CloudFormation until you run the transform on it. Okay. The second thing is in our resources, this is a function. Now this is doing several things. We're declaring what it is. We're telling where it's located. In this instance, it's going to be in an S3 bucket. We're going to say the handler, what should I fire or what should I invoke when this function is called? And that'll be a function under a file called index and a function called getHTML. This is Node.js 6.10, which is not even available anymore. Need to update my slides. Okay, we need to change colors and update the domain. Got it. All right, someone write that down? Anybody? Okay. All right. Policies, these are Amazon managed policies. You can do your own, but these are very helpful. So for instance, in this one, we're doing Amazon DynamoDB read-only access. What you're not seeing here that I need to add is you can also declare which table. So if I had a table I'm building down lower, I could pass that table name through a reference. So I don't have to name that table. I just pass a reference to the logical ID, and it will granularly set that permissions, okay? Really important when you're setting permissions is very easily you can get silly granular in SAM, okay? So always do least amount of access, okay? And so this would say only this table, okay? Then the last thing we have is what event is going to trigger this Lambda, okay? And so with this, I'm using an API, and I'm telling it the path. Now this is a proxy, and so it's a greedy, so it can say, hey, anything past the root, I want you to trigger this Lambda, and then we'll handle everything, anything. And then any method. Now I could say this could be users and post. Okay, so I can say 1 Lambda for post, 1 Lambda for get, 1 Lambda for put. You may or may not do that, but you can get really granular. And when we're building out Lambdas, we want to make sure that we're building in a way that we keep it very simple and we don't repeat ourselves, okay? I really believe in the single responsibility model when we're building Lambdas. For the Lambdas, they should do one thing and do it really, really well, okay? So, and then the last thing, I do have a table here. The last thing is a list table. So I could actually ref this list table. So I'd put bang ref and the list table, and it would only tie the permissions in to this table. So what that enables is this, okay, and that's kind of ugly because it's not dark and laid out, but the picture becomes this. And this is kind of a diagram of what it looks like in the CloudFormation designer. So the second part of this is, and this is where it really gets powerful too, is the command line, okay? So this is something you install locally on your machine, and it allows you to build serverless applications and test locally, okay? Now, I get a lot of questions on that, okay? And this goes back to the 12-factor on how are we testing and the parity of our environments, okay? So what I encourage is SAM local, and it kind of enforces best practices the way it's built, is the only thing it's going to replicate locally at the moment at least are the API gateway and the Lambda. So I can actually type SAM local start API, and it'll bring up a full API with any of the Lambda functions in there with endpoints. Okay, so what you're then able to do is locally you can hit this API, it'll be, localhost 3000, something like that, and test against that. Okay, so quick iterations, and as you change your Lambda code, you don't need to restart it. It's automatically going to invoke the newest. Okay, so quick iterations against your Lambda to make sure it's working. Once it's done, then I push it. Okay, I commit it to my repo, and that repo will build it out in my development or alpha or whatever your tool chain does. Okay, so SAM local gives you a lot of power. You can get the logs. It does a proxy style API gateway, open source. It runs a Docker Lambda that's open source. It can tail production logs, so you can look at. You can say, give me my logs, from this. And it can help you build native dependencies, build in native dependencies. One of the things it has in this is there's a thing called SAM build, and so it will take your application and crunch it down, very small. So you're getting some of the smallest applications you can get. It gets rid of stuff you're not using for testing. You can add ignore files for it. A lot of power there. The other thing you can deploy, you can deploy your SAM if you're not using the CI/CD. You can do a build, package, and deploy, which that builds it out to the smallest. It packages it and puts it up in a folder in the zip, and outputs a new template that tells deploy to work with, and then you deploy your code. So you can deploy right from SAM. It's very easy. When you're doing local development, single developer applications, maybe that works fine for you. But I do encourage you to look at the CI/CD stuff as well when you're building on this. So you can find information about this at Amazon.com, serverless SAM. All right. 11, logs. It always amazes me when we're talking to people. What do your logs say? I don't know. Okay, treat logs as event streams. Okay, these should be things that are going on that you can respond to. And this works really well. Your console output automatically is collected. When we're using serverless, it does metric collection. They're considered a universal write. Okay, we think logs should be universal and should be an always on thing. Okay, so the cool thing about it is all your logs, all your outputs, everything like that from the processes are pushed to CloudWatch. And in CloudWatch, it's an event. It's an event stream. I can react to things in a CloudWatch. I can set alarms. I can get insights. I can collect events. I can do reporting. I can do all kinds of things. But critically, what I want to do is, when maybe I'm hitting concurrency and I don't know it. Maybe I got code that's failing and I don't know it. I should have alerts set up in my application that are telling me these kind of things. Okay, so logs are universal write, and we believe that in serverless as well, and we encourage you to use them and react to them. All right, and the final factor, 12 factor here, is admin process. Okay, run admin management tasks as one-off process. Okay, and this is a lot of times like database migrations or different things like that. If you're a Ruby guy and you've done, or gal, and you've done some data, they have the migration, things like that. I'm not, obviously, as you can tell, a Ruby person. But there's different things you can do. Well, this is a little different in Lambda. It doesn't apply because Lambda, you already limit your functions based on use case. As we talked about earlier, we really want Lambdas to be single responsibility, to do one thing and to do it well. Okay, so if you need to run a one-off process, things like that, build a Lambda to do it. Okay, you just use another Lambda. All right, you can trigger it from a CloudWatch event. You could trigger it from your, let's say you need to do some migration and your build needs to trigger it. So you can do these one-off admin processes, but it's easy to do by triggering a Lambda. So again, this doesn't apply in including in the application, because that's what the 12 factor would tell you, but you can include it in the build process. You can do it one-off through a separate Lambda. All right. Well, how do we do? Let's see. So we covered code-based dependencies. We match on a lot of things, okay? But the purple stars you see work similarly. The white is not relevant. And then number 9 is a half. We talked about you don't throw away Lambdas, but speed does matter. So as we've seen, 12 factors design can still be applied to serverless without issue. All right, and I hope that encourages you if you follow this. So does this serverless stuff really work? Are people applying this? And I want to show you a couple examples of companies that are doing this and doing it well. What are the benefits they're getting out of serverless? So this company called Pinpoint, they were having issues. They needed to simplify both their internal workflow and analytics process pipeline, as well as the process for building microservices across. So what they did is they switched from using Kubernetes to AWS Lambda, and they rewrote their entire API tier, internal workflow and analytics processing time. So here's what they got. They deploy fixes and features multiple times a day. Okay, deploying to Lambda is easy. And because we build microservices, because these are isolated, because we've built decoupled applications, I can push code very easily, and I can do it a lot, okay? And I can roll back if there's a problem, okay? So it makes that deployment and an updating process easier, much easier, okay? I've been that developer that works on the monolithic application, and they come to you and go, look, we want you to change this. I'm not touching that. You know, and you know it because you know there's a possibility when I push code, it's gonna break theirs. Mine's gonna work fine because I test in production and my code always works. But some people may disagree with that. So, all right, next one, Autodesk, okay? So they were setting up accounts was a bottleneck. So they needed a way to set up multiple accounts. So they built Taylor, a solution for using DynamoDB for data persistence and Amazon API Gateway for API endpoints. They automated all processing using Lambda. So now they submit an online form to request a new account, and the API request triggers the account creation process. It's instantaneous. Saves 99% of previous costs. I don't care who you are, that's a pretty good stat. Well, it's not 100. Okay, it's 100. Okay, all righty. Supports queries by account number, email address, a lot of power going on. Okay, so Lambda is more than an API or an endpoint. It's more than just a cron. It's really the Swiss Army knife of AWS. It could be used for so many things, limited only by your imagination. Okay. FINRA validates the data of 50,000 broker-dealer OATs, that's cool, order audit trail system, files and formats them according to 200 rules. Okay, so they do a lot of stuff. They needed a solution that could scale with processing demand. They needed scalability, right? Okay, and that's what serverless does well. So the data is ingested in Amazon S3 via FTP, and AWS Lambda performs the validations. EC2 manages data feeds coming into and notification going out. Lambda going out of AWS Lambda. Amazon SQS, so they're queuing it up, is used for input, output messaging verification, while Amazon VPC partitions the system into separate tests and production accounts. Wow, they took a lot on here. Delivered solutions in 3 months, so they built it fast. Okay, accelerated data validation by 700. Okay, if 99% is good, 700, that's better. Okay. I'm not great at math, that's better. Okay, so a lot of stuff going on. Increased cost efficiency by a factor of, I'm gonna just do this for this 2. All right, I can go to 4 if I take my shoes off, but we're just gonna stay here. Okay, so good to understand that this is not something that we're just talking about theoretically, it's something really happening. All right, so what's the final? What's the FinAC on this, okay? So as we reviewed the 12-factor methodology for applications, we've seen which factors do and do not apply. Okay, some do, some don't. Okay, thinking about code reusability and how to scope your functions to the smallest size necessary provides many benefits. That's not different, right, for serverless. Smaller code, faster. That's just reality. Factors related to underlying process management, network ports, concurrency, and admin process are largely not an issue. And best practices for serverless align pretty close with the 12-factor guidance already, so you might be really close to meeting the 12-factor bar already. A couple of websites I want to leave you with. The first is our serverless, SAM. So Amazon.com or aws.amazon.com/serverless/SAM. This tells you a lot about SAM. If you are trying to get into serverless or if you're doing serverless now, use a framework. Okay, SAM is the one I prefer. It's the one AWS puts out. I love it. There are others. There's good ones out there, but I encourage you to use a framework. Okay, the second one I would tell you is just serverless itself. If you're looking to know about serverless, aws.amazon.com serverless. That'll tell you a lot about it, help you get started. I also encourage you to follow my handle, EDJ Geek, on Twitter. We do post a lot of stuff, announcements. I do a lot of like Sam tips. You know, here's an easy way to have a template to always start with, things like that. And that's it. Now I will tell you, I can't take questions up here because of the format, but I will be wandering around the halls. I'll be out back there, glad to answer any questions I can. I encourage you to fill out the survey. Guys, thank you, Team Green. Have a good one. Thank you.